Hi everyone, and welcome to Physics with Mr. Simons, where we simplify physics and we get you exam ready, right? Today's lesson, we're looking at a past exam question paper, November 2016. We're looking at the chemical equilibrium. And I've chosen them in such a way that I can show you the different variations of these exam questions. How we test the same thing, but we have slight differences, especially when it comes to calculating your Kc value. All in all, there's about 8 different ways we can test Kc. So question 6. Hydrogen gas reacts with sulfur powder according to the following balance equation. So we have hydrogen gas, I have sulfur in solid form, and I have hydrogen sulfate in gas form. Delta H less than 0, meaning we're dealing with the exothermic reaction, and the system, they say, reaches equilibrium at 90 degrees Celsius. Now 6.1, they want us to define the term chemical equilibrium for 2 marks. 6.2, how will each of the following changes affect the number of moles of H2S at equilibrium? Choose from increases, decreases, or remain the same. Addition of more sulfur, an increase in temperature. Use Le Chatelier's principle to explain the answer. So I've broken this question into 2 parts so that I don't squash too much information in one place, right? So we're going to answer this section first. As I said, pause, see what you can answer, what you understand, and what you don't understand, I'm going to explain to you now and get it into your head, right? Define the term chemical equilibrium, right? It's simply the stage in a chemical reaction when my rate of my forward reaction equals the rate of my reverse reaction. So the rate at which I'm forming products equal the rate at which I'm forming reactants. They are balanced. Right, 6.2, how will each of the following changes affect the number of moles of H2S gas at equilibrium? Choose from increase, decrease, or remain the same. The addition of more sulfur. As you can see, sulfur, there's a solid, right? The only items that affect equilibrium or disturb equilibrium in a closed system is temperature, pressure, and concentration. So adding more solid here will have no effect on equilibrium, therefore it remains the same. 6.2.2, an increase in temperature. According to Le Chatelier, what would happen? Alright, so H2S, we want to know how would it affect the product. The product have to decrease. Alright, and that is because my forward reaction is exothermic. According to Le Chatelier, an increase in temperature will always favor the endothermic reaction, meaning the reverse reaction. Remember, if the forward reaction is exothermic, the reverse reaction is endothermic. So the increase in temperature favors the endothermic reaction, the reverse reaction, then H2S will get less, and H2 there we should get more. Alright? So increase in temperature favors the endothermic reaction, so the reverse reaction is favored. Right, so that is my 1, 2, there I forgot the red tick, but 3, 4 marks, right? So I hope you follow, hope you understand. So that's some basic theory. Now let's go to calculations questions. Right, now question 6. They say the sketch graph below was obtained for the equilibrium mixture. Right, so there my reactants decrease till they reach equilibrium. My products was formed till they reach equilibrium. And there we have T1. Now for 6.3, they say a catalyst is added to the equilibrium mixture at time T. Redraw the graph above. On the same axis, complete the graph showing the effects of a catalyst on the reaction rate, right? So assume you remember catalyst speeds up the reaction without partaking in the reaction. It's like that boy you know at school that will always start trouble without partaking in the trouble. Like, yo, did you hear what that one say? I'm not going to leave him. You want to leave him? And next thing you know, there's an unnecessary fight happening at school simply because we had a catalyst that want to see drama. I hope you're smart enough not to fall for those types of catalysts. Right, but the speeds up, so therefore if that is my forward reaction and that's my reverse reaction, it should increase vertically first and then horizontally it should read a new constant at a higher rate. Alright, But yeah, we'll answer that on the next page. Initially 0.16 mole H2 and excess sulfur are sealed in 2 decimeter containers. So my volume for the container is 2 decimeter cubed. And the system is allowed to reach equilibrium at 90 degrees Celsius. Exact amount of lead nitrate or PbNO3 solution is now added to container so that the hydrogen sulfate present in the container at equilibrium is converted to lead sulfide according to the following balance equation. So there they've given us the equation. And they say the mass of PBS precipitate. So PBS there is 2,39. Calculate the equilibrium constant Kc for the reaction H2 plus S H2S. So you see you have H2S, in that equation I have H2S. So using the mass of PBS, I'm going to have to work out how many moles of this I have, so I can relate it back to H2S. That H2S then is brought over here, and we work from the one equation to the next equation. As you can see, it's a nice 9 marks. Right, so let's go look at the solutions. So 6.3, the sketch graph below was obtained for equilibrium. So a catalyst is added. So as I explained to you, there the catalyst has to increase the forward and reverse reaction. So you see there, we give you a mark. Vertical parallel lines, meaning the spacing is even between them, to show a sudden increase in the rate of the forward and the reverse reactions, right? So there, increase in forward, increase in reverse reaction, right? Then we have horizontal parallel lines that is higher than this. That is to show a constant higher rate for both forward and a reverse reaction. So 1 mark for each. That is where you get your 2 marks. So as I say, catalyst speeds up everything. Everything happens faster than they're supposed to, but the catalyst itself don't partake in the reaction. Right, now let's go to the Kc question. So they say initially we had 0.16 moles H2 and an excess of S in a 2 decimeter cubed. So you see here for equilibrium concentration, I'm dividing by that same 2 decimeter cubed. Exact amount of PbNO3 is now added to H2S present in a container at equilibrium and is converted to PbS according to the following. So they gave me 2,39. So my moles of PbS, remember moles equal mass over molar mass. So my mass there is 2,39 grams. The molar mass of PbS adds up to 239. Sulfur being 32. That means that is about 207 for lead. Plus 32 gives me 239. If we divide that, I have 0,01 mole of PbS. Now there you can see in the ratio 1:1:1:2. There's 2 in front, only 1, 1, 1. Right? So my lead, my molar value for lead sulfate ratio format should equal H2S. So moles of H2S equals 0,01 mole. So 1 mark there for correct substitution, 1 mark for relating that in the ratio 1:1. Alright, now we have to calculate the equilibrium constant for the reaction. We have there, so in my column I can only use my gases or aqueous. No solids. So I have H2 there being 0,16 initially. Remember H2S hasn't formed yet, so my initial quantity of H2S is 0. Then I need to find the change, quantity equilibrium and equilibrium concentration. Right, so at equilibrium, my moles of H2S was 0,01. So you see there, I've labeled for you the process. I'm going from 1 to 2 to 3 to 4 to 5. So there I started with 0,16. That was what's given to me. Then also from PBS, I know at equilibrium, because they say at equilibrium is converted for PBS. So this is at equilibrium, I have 0,01. Now I need to remember for my products, plus the value, for my reactants, minus the value. So here to get to 0,01 means I've added 0,01. Right, so there from second to third. For the change, we always use the ratio. So the ratio of this is 1:1. Alright, so if I have 1 there, my molar ratio between the two 1:1. So that's 0,01. That must be 0,01. But remember, for reactants, we subtract. So 0,16 minus 0,01 gives me 0,15. Right, so that's where I went next. Now to get my concentration, I'm going to divide by 2. So 0,15 divided by 2 gives me 0,075, and 0,01 divided by 2 gives me 0,005. Right? For Kc, I assume you remember, it's always my concentration of my products divided by my concentration of my reactants, right? So that is 0,005 divided by 0,0075, which then gives me 0,067, which equals 0,07. Right, and it has no units, right, because it's a ratio of the same item. Right, so 1 mark here for understanding its plus, another mark for using the ratio, another mark for getting the value 0,15, 1 mark for dividing by 2, 1 mark for correct Kc value, 1 mark for correct substitution, 1 for answer. But there was my initial 2 marks for relating PBS to H2S to H2S there. Alright. So I hope it makes sense for you. You can pause, rewind, go through it again slowly. I'm still doing more of them. Right. We will calculate Kc, but we have to get used to using the table and filling out our values in the table. Right. I wish you nothing but the best. God bless. Bye.